All right, so today our goal is going to be dealing with prisms, and what you have here is a rectangular prism, or sorry, triangular prism. The way you establish what type of prism it is what type of base it has. So what we're looking for is identical twins. So I'm looking at this triangle here. And this triangle down here. The way it looks like they're the same, but we're not allowed to go on look. So if I read the whole problem and it says triangular cross-section dot, they're telling me it's a triangular prism, which implies that these are exactly the same triangles. The other thing is I need to find the area of that triangle, and we've got several formulas for area of a triangle from the previous chapter. We have this 1/2 base times height. We have Hero's formula if we know all three sides. The 1/2 base height only works if we have a right angle somewhere in the picture, and you can see there's no right angle established here. But if we look at the triangle that's there, if you look at the Pythagorean theorem, if you test out if it's a right angle or not, if it's a right angle, the hypotenuse is the longest side. So this might be a right angle right here. If you test it with the Pythagorean theorem, short leg squared plus other short leg squared should equal the longest leg squared. And if it does, 36 plus 64 equals 100 is true. That means that this is actually a right angle, so this is a right triangle. So we can use just simple 1/2 base times height to find the area of the base. So that's one thing about triangles. You have to find the area of the triangle within these problems. How do you find the area? We have the two techniques. That's one technique. Area is equal to 1/2 times the base times the height, which is 24. Just to refresh your memory, the Hero's formula technique that we learned prior to break, we want the semi-perimeter. So half the perimeter. 14 plus 10 is 24, half of that is 12. And the area is going to equal the square root of that number times that number minus each of the three sides. 12 minus 6 is 6, 12 minus 8 is 4, 12 minus 10 is 2. Then you grab a calculator and you multiply 12 times 6 times 4 times 2, which is 576. And then you square root that, which is 24. So again, if you can't assume a right angle, you can't do that. So if they don't have a right angle drawn, you don't want to go through the trouble of figuring out if it's a right angle or not, then you can use Hero's formula. If it weren't a right angle, if it was 5, 6, 7, for example, that wouldn't have fit, then this is the technique you would have had to use. All right, so keep in mind that how to find the area of a triangle might be necessary in these problems, so make sure you have both those formulas under control. Right? What they're asking me to find here is the total surface area, the lateral surface area, and the volume. So it's important that we know what these dimensions represent, or what these measurements represent. So the total surface area is the area of all the faces. So if you take a look, total surface area is the area of the top triangle, the bottom triangle, the front rectangle, the backside rectangle, and the other backside rectangle. So we have 3 rectangles, 2 triangles. And I could just find each individual area. So obviously the top triangle is 24, the bottom triangle is 24. We've already got that figured out, right? 24 inches squared, 24 inches squared. The rectangles, the front rectangle, so I'm going to say A sub F for the front rectangle, is length times width. So 10 times 15 is 150 square inches. The back right, A sub BR for back right, is the length times the width, so that's 8 times 15, which is 120 square inches. And the back left is length times width, 6 times 15, which is 90 square inches. So in general, with prisms specifically, you can do total surface area this way. Find the area of all the surfaces, add them all up. All right? So we have a 24 square inch top, a 24 square inch bottom, a 150 square inch front, a 120 square inch back right, a 90 square inch back left, Add all those numbers together, that's the total surface area. So let's say TSA. Total surface area is the sum of those 5 numbers. So 150, 120, 270, 360, and 48 is 408. Feel free to use a calculator to punch it all in if you want to. Also, just have your calculator 24 plus 24 plus 150 plus 120 plus 90. 408. Okay, so that's how you find total surface area. That's a technique with a prism. Find the area of all the faces, add them all up. That's the total surface area. And you're applying whatever the specific area formula for that specific shape is. We had 2 triangles. We did the triangle formula, one of those 2. We had the rectangles. We used the rectangle formula to find those 3. So identify the shape, use the proper formula, evaluate the area for those things. Lateral surface area, if I were to describe lateral surface area to you, it's the area of the sides, not including bases. Again, lateral surface area of a prism. A prism has 2 identical twin bases, and then you got a whole bunch of sides. So if I'm doing lateral surface area, I only want the area of the sides. The bases don't count. I don't care about the top or the bottom, I care about only the sides. That's what lateral surface area is. I've already done all the math involved to find the area of the sides individually, so if I just add these 3 numbers up, that'll be my lateral surface area. So my lateral surface area is equal to 150, 120 is 270 plus 90 is 360 square inches. So that's how you do lateral surface area. And again, it's just piecing it out, adding up the areas of each individual piece. Okay, I'm not using the all-encompassing formulas for these right now. I'm just kind of going through the strategic technique of finding the area of all the pieces, adding them up. All right. Now the final thing to ask for is the volume. And volume is area of base times height. Be careful with the word height. A lot of people see height, they think up and down. If you identify the 2 bases, the distance separating the bases is the height. So in this case, I got a base here at top, a base here bottom. The distance separating those bases is 15 inches. That's the height. If my prism were laying on its side, so a base is here and a base is here, then the height would be going horizontally instead of vertically. So when you see height, don't think up and down always. Just think how far apart are the bases. That's what height is. Okay, so the 2 things we need to know are the area of the base, which is 24 square inches. We've already figured that out. The height, which is 15 inches. We already know that. So the volume of this thing is going to be 24 square inches times 15 inches. And notice the units that we're getting out of it. So area, surface area, lateral surface area, it's all square inches because we have 6 inches times 8 inches. That makes square inches, right? And all this. So all these are square inches for area. With volume, I'm taking the area unit, inches squared, times the height unit, inches. That's going to make inches cubed volume. 24 times 15, again, calculator usage is just fine. We're going to get 360 inches cubed. Okay. It is just coincidental in this case that the volume and the lateral surface area are the same number. They aren't the same answer because lateral surface area is square inches, volume is cubic inches, so they're not representing the same measurement, but they do have the same numerical value. That's just coincidental. That doesn't always happen. All right, so don't expect that to happen often. But again, that's a technique for doing it. That'll work every time for prisms. Prisms having straight edged figures for the top and the bottom or the bases, and then straight edges coming down. If you start getting curvy sides, then we have to have more elaborate formulas. So is everybody comfortable with how to do that one that way?